Hello everybody, today this video is going to be on the basics of complex numbers. We're going to talk about how to simplify negatives under the radical, what I is, and how to simplify different expressions with imaginary numbers. All right, so first we need to identify what the complex numbers are. Complex numbers are numbers that can be written in the form a plus bi, where a and b are real and I is imaginary. I, therefore, is just the square root of -1. We've always told you can't take the square root of negative numbers, but that's just a rule that we made up. And we're just going to say, hey, there's no real number when you square it equals -1. But we're just going to decide that there's a number, we're going to imagine it, we're going to think of it, we're going to invent it, and we're going to call it I. All right? Therefore, if we square both sides of that definition, I squared equals -1. So when we're simplifying radicals with this, you know that like the square root of 4 is 2. So the square root of -4 is 2i. That negative is just coming out. It's the square root of 4 and the square root of -1. So it's 2i. And then same thing here with 9. That would be 3i and 5i for -25. But if it doesn't work out to a whole number, that's fine too, right? We can do this in the square root of 4, square root of 3, square root of 4 is 2, so it's 2i root 3. The I is coming from the negative. And if I have the square root of a negative number and I square it, well, it's still that negative number, right? One of our biggest things that we have to talk about is the powers of I. I to the first power equals I. That makes a lot of sense. And then we defined I squared as equaling -1. So if we break out this into I cubed, right, that's I squared times I. Well, that's -1 times I. So that's -I. And then I to the 4 would be I squared times I squared, which is -1 times -1, which is +1. Well, let's keep going. I to the 5th would be I to the 4 times I. Well, that's 1 times I. So that's I. Okay. I to the 6th would be I4 times I squared, which would be -1 times, it would be +1 times -1. So that's -1. I to the 7th would equal I to the 4th times I to the 3rd. So 1 times -I, so -I. And I to the 8th would equal I to the 4th times I to the 4th, which is 1 times 1, which is 1. So imaginary numbers are behaving unexpectedly, right? When we raise them to higher and higher exponents, they don't necessarily get larger. They're kind of cycling through the same 4 values here, right? Like I, -1, -I, 1. And so if I gave you I to the 9, you could probably tell me that it's I, just following this pattern. You could probably fill in the next 4. So the rule here is that it's a cycle of 4, right? So we want to divide the exponent by 4 and use the remainder as the exponent. We really only need to know these guys and then just see what step of the cycle we're on. Since it's 4 long, we divide the exponent by 4, and then the remainder is telling me what step of the cycle I'm on. So if it's, for example, if I was doing I to the 73rd, right? 73 over 4, 18, remainder 1, I believe. So that's telling me that this is I to the first power, so this is just I. That remainder is telling me what step of the cycle I'm in. All right. So in practice, what this looks like is, so if I have 5i squared, that's 5 times I squared is -1, so this is -5. 3i all squared, the quantity 3i squared. So 9i squared, 9 times -1, -9. And it's okay if you can combine some of these steps in your head. 8i cubed, 2 cubed is 8, I cubed is I cubed. I cubed is -I, so -8i. At the end of the day, you should not have an exponent on I. You should always have it simplified down to either positive or negative I or positive or -1. We don't need exponents on I. -3 to the 4th power would be 81, and I to the 4th power would be I to the 4. I to the 4 is 1, so this is 81. All right. 4i to the 23rd. Well, this would be 4 times I to the 23rd is -I, because that is I to the 3rd, right? Divide 20 by 4, you get, we don't really care that you get 5, and then you look at the remainder, that's 3, so it's on the 3rd step. So it's -4i. 5i to the 82nd. 82 over 4 has a remainder of 2, so that's 5i squared, so it's -5i, because I squared is -1. -3 times I to the 4, because 48, the 4 goes into 48 evenly, so it's on the 4th step. And I to the 4 is 1, so this is just -3. 15 times I to the 37, 4 goes in there 9 times with a remainder of 1, so it's just 15i. All right, that's the basics. Stay tuned for part 2.